When I first started working on robotics, I honestly had no idea what I am doing. And instead of starting with something simple, I decided to build a humanoid robot in my second year. And looking back, that sounded completely crazy. At a time when people were already building robots that could walk, run, even do backflips. So I opened Fusion 360 and started designing the basic structure. I was using simple tools like aluminum extrusion and basic DC motors, stepper motors, and whatever the DC, servo motors I got from market, because I at that time, I cannot afford those kind of feedback based servo. They are really expensive. And honestly, I choose a lot of those part randomly. I didn't know exactly what motor I needed. I don't know what extrusion size would be perfect. So I go with the most basic one, that is 2020 extrusion or 2040 extrusion. And I collected the aluminum extrusion, motor, electronics, and other components slowly. And slowly I started putting everything together. So first come the base, then the rear chassis, then the support structure, and slowly something started looking like a robot. But at that point, I wasn't very confident that this thing would actually work. I was, basically building it and figuring thing out at the same time. One advantage I had was access to hardware through my college. Most of the tool and component I used came through my college idea lab. That access made a huge difference, because that, I cannot afford those Bosch or uh, drilling machines and all. So because when you don't have a big budget, being and able to experiment with real hardware is incredibly valuable. And at that time, I didn't even own a 3D printer. So I found another solution, that is PVC sheet, that is PVC sheet or corrugated sheet. I cut multiple layer and stacked them together, glued them, and using those super glue, and I created the structure of robotic arm. It wasn't fancy, it wasn't industrial grade, but it worked, and that's more than sufficient for me. And after assembling the mechanical structure, I started working on electronics parts. I had to calibrate the motors using servo tester, and I need to do a lot of these. And there are a lot of small problems are there, and a lot of testing is required. A lot of things that didn't work at first time, but slowly things started moving, and that was the moment when I started getting some confidence. Maybe this could actually work. So the robot have three servo motors in each of these arms, so total six servo motor in the entire arm system, or I could say an entire robot, because I'm not working on the finger part at moment. So I wanted to solve the basic problem first. So I focus on the main arm movement. So for the electronics, I experimented with the Arduino board, Arduino Nano ESP32, and I use Arduino Nano expansion board to control multiple servos at a time. And a lot of this development happened inside my hostel room, and here you can see this is my room is really completely mess, but honestly those were some of my favorite engineering days. And you have a robot lying on floor, wires everywhere, electronics on table, CAD open on your laptop, running different things at a time. And this is something that make everything memorable. So once the hardware started moving, the next challenge was, how do I actually control this thing? So I started learning inverse kinematics, and honestly, I use AI at that time, because I was not very aware about inverse kinematic, how exactly I can use that, and how exactly can I implement that on my Arduino, or using OpenCV to control the overall art. So I worked on the control software and started figuring out how to translate human movement into robot movement. And at that time, I got to know more about media pipe, and I started, doing some trial and errors. And over that time, I, got a lot of new concept, generate, different concepts at the time. And I really think that this is the time when I learned a lot of things. And then I started experimenting more with the computer vision, and this became one of my favorite part of the project. So instead of adding a sensor for every single joint, I want to use, computer vision to control each of these joint. So I use OpenCV to track my movement, and suddenly the robot could follow me. I could move my arm, and the robot can replicate that exact movement. So this is not complicated, for people's nowadays. You can use this easily using Claude and all, but at that time this was, a really great memories I have. So using just a camera and computer vision, and I can control my entire robot. So after getting the arms working, I started working on the body. So robot need a mechanism to adjust its height, so I use stepper motor, because stepper motor is something that I have already worked on, and the driver that is called TB6600, which is really cheap. So I'm using Arduino Uno, not very fancy board at that time. So using that board, I'm able to control the overall, the rotation and the amount of rotation that stepper motor is needed to make. And using that, I can control the overall height of the entire robot chest. So for this, I am using, those lead screw, because your normal servo motor or stepper motor cannot hold that amount of load. So lead screw system can reduce overall system and, overall complexity or the hardware, and this can take a lot of payload on top of it. So here you can see it can go up and down again and again. And another part of the robot was alive. So here, once the robot could move, I realized something, that a humanoid robot isn't only about robot or mechanical system. It also required expression. So I started working on head. So at that time, I still didn't own a 3D printer. So once again, my college helped me with that fabrication part. So I went to my college and 3D printed this head part. So before building a proper 3D printed head, I want to work on the the basic structure that I want to go with. So I started working with the expression part. For this, I'm using 8x8 LED matrix, and this is something that I always love to make expression with. So initially, I also want to add both eyes and mouth, but over the time I thought, let's go with eyes only, because mouth make it more complex and uh, you know making it more design constraint kind of thing. So I go with the eyes only, and I remove the mouth and focus on the eye part. And with some multiple simple animations, I made this small expression which make the entire robot, and then the entire robot suddenly start feeling much more alive. But there was one problem. Computer vision was great, but I couldn't rely on it for everything. So I tried a lot of different way, but I cannot control the overall robot, very precisely. So I want to build my own controller. So the one way that you can use is to use potentiometer or encoders that will send the angular data to your servo motor or your microcontroller, and that data would be sent to your servo motor to mimic that exact part. So I started working on the controller part. This is not very fancy. I really want to go with the cheapest way. So I used encoder. So that is the potentiometer. Most probably you can see that on your ceiling fan regulators. So I use that, and using the signal pin, I send the analog values, and that analog values are converted to digital or PWM signal for the servo motor. So this project was built around the end of my second year of college, and watching this old recording now feels really emotional. At that time, I didn't have an expensive 3D printer. I don't have a powerful computer. I don't have the expensive actuator, but still I tried to build something like this, and somehow it worked. So of course there are so many things I want to improve. The motors are one of the biggest limitations, but if I want to, eventually use reinforcement learning or machine learning or implement some AI, the recent AI advancement into this, then I really need to go with those feedback based servo motor, because I cannot rely on these digital servos. So I need better position control, better torque control, better sensing, and eventually I want to take this project much further. But for what I have at that time, I genuinely proud of it. So what's next is the something that I could ask myself at this point, and that's probably the biggest thing I learned from this project. So you don't always need the perfect hardware. You don't need the most expensive component. You don't need to know everything about you when you start. So sometimes you just need to start building, start with whatever you have, making something, break it, fix it, learn something, and then make the next better version of it. So this is things that I want to improve. There are a lot of things to improve the electronics, improve the control system. And this video I want to upload for a very long time, so I thought let's do it right now. So it's just the beginning of the next version. So I am Vikas, I love robotics. See you next time. Till then, bye.